The problem set for this video is on Pythagorean theorem and special right triangles. So I'll quickly recap on those topics and then we'll do these 4 problems on this page, okay? So the Pythagorean theorem only works on right triangles. That's really important, okay? And what does it say? Well, if we call one of the sides that's not the longest side A, the other side that's not the longest side B, the longest side we call the hypotenuse is C, okay? By the way, these are lengths, okay? So the relationship between the lengths of the sides is A squared plus B squared is equal to C squared. Again, C is the hypotenuse, the longest side. If we square it, its length squared is the sum of the square of the other two sides. Squares of the two sides, okay? That's what the Pythagorean theorem says. This comes up quite often on the SAT exam, at least the practice problems that I've seen and done. Okay, and then we have 2 special right triangles that you should memorize, okay? If you have a 30, 60, 90 triangle, okay, the side opposite to the 30-degree angle, if it's length 1, let's say, this is always should be the reference, 1, okay? The side opposite to the 60-degree angles has to be longer. So, and what's the relationship? It's root 3. Okay? So you can think of it as to go from the 30-degree side, the side opposite to the 30 degree, to the side opposite to the 60 degree, you multiply by root 3, if you know this value over here. Similarly, the hypotenuse is length 2 then. So, again, if you have the length of this side over here, that's opposite to the 30 degree, you could just multiply by 2 and you have the length of the hypotenuse, okay? That's one triangle. I won't derive why this is the case here. You could probably go watch some other videos to find that out if you're interested, or you just memorize it, okay? This one is a 45, 45, 90 triangle, the other special triangle you should memorize. Okay, this is an isosceles triangle, by the way, because these 2 angles are the same, so these 2 sides have to be the same. So if one of them is length 1 for simplicity, the other has to be length 1 as well. And actually, you can use the Pythagorean theorem exactly to get the length of this side. 1 squared plus 1 squared, that is 2, right? So 2 equals C squared. C is square root of 2 then, exactly. So we can use the Pythagorean theorem to prove this. This one's easy to prove, and I just explained it to you. Okay? And by the way, we can also check the Pythagorean theorem for this. 1 squared is 1. Root 3 squared is 3. So 1 plus 3 is 4. C squared is 4. Square root of 4 is 2. Works out as expected. All right. So you got to memorize these 2 triangles, basically. It should help you out a lot in terms of getting sides of the triangle quicker. All right. Let's begin this problem set then. As always, you should try the problems first yourself and then come back to this video to see how I think through it, how I solve it. Okay. In the figure above, if AD is equal to BD, which they marked the length there, which is 2 root 3, what is the length of AB? Okay. You got to be careful here because you would think that this triangle ADB is a right triangle, but it's not. Just because it's an isosceles triangle, it's not a right triangle. And you can clearly see that. This doesn't have the notes, figure not drawn to scale here. So you could more safely assume that this is clearly not 90 degrees. It's not a right triangle. You can't use the special triangles, okay? But maybe we can use the fact that this is isosceles, as I said. If this is 30 degrees, okay, then this guy over here has to be 30 degrees as well. Does that help us actually? I'm just marking it right now as an observation, okay? You probably have to use this right triangle over here somehow, okay? And how can we do that? By the way, we also cannot use Pythagorean theorem to get this side over here, again, because it's not a right triangle, okay? Now, let me start thinking. If this angle is 30 degrees, how does that help us? Well, I know this angle then, because this is also 30. They sum up to 60, right? So this is 180 minus 60, which is 120 degrees, right? So this angle over here is 180 minus, we can use the exterior angle, now that I realize it, but 180 minus 120 is 60. This is an exterior angle, so it's the sum of these two, by the way. So you get to that. So this is actually a 30, 60, 90 triangle. This is triangle ACD, 30, 60, 90, okay? So if this guy is root 3, the hypotenuse is root 3, the side opposite to the 30 degrees is half of that. So it's root 3 over here. What are we interested in, by the way? We're interested in AB, okay? So if this is root 3, then this side over here opposite to the 60 is root 3 times root 3, which is 3, okay? Now we can use Pythagorean theorem to get the length AB because we have AC and CB. So 3 squared plus how much is this? This is 2 root 3 plus another root 3. That's 3 root 3 quantity squared is equal to our length AB squared. Okay? This is 9 plus this is 9 times 3, which is 27. Okay? This is 36, so AB is 6 then, after we take the square root. Answer C. Okay? So we could have did that, or you could just realize that this triangle ACB is also a 30, 60, 90 triangle. 30, 60 up here, 90 over here, okay? So this over here is 3, right? So the hypotenuse is 3 times 2, which is 6. Same thing. So that's a different way to approach it. You didn't have to use Pythagorean theorem, actually. Okay? Now that I see it, that would happen actually faster than this, but you can clearly see this works out as well. Okay? Goes to show, once again, that sometimes one method is more efficient than another. Okay? You have to be able to see it, though. Okay, in triangle ABC above, BD is root 3. They marked it for us. What is the perimeter of triangle ABC? We got to be careful to answer the question perimeter, so let's even underline it. Okay, if this is root 3, this is a 30, 60, 90 triangle, ABD, okay? This is root 3, then the hypotenuse is 2 root 3, and over here is root 3 times root 3, which is 3. Okay? That's that triangle. We solved this triangle ABD. Now we can solve for CBD. This is also the 30, 60, 90 triangle. If this side is root 3, then this side is 1, and this side is 2. Okay? See how quick it is if you know these special triangles well? So perimeter is the sum of all the lengths of the outside. So 2 root 3 plus 2 plus 4, which is 6 plus 2 root 3. Answer is B. Okay? Figure above, AB equals 6. BC is 8. That's hard to mark, so I won't mark it for now. CD is 5. What is the length of AD? Okay? Well, if BC is 8, well, we know what AC is. AC squared is AB squared plus BC squared by Pythagorean theorem. The Pythagorean theorem, right? Side squared plus the other side squared is the hypotenuse squared. We have these two, so 6 squared plus 8 squared, which is 36, plus 64, which is 100. So AC is 10, after I square root it, okay? And then we can use the Pythagorean theorem again, because AC squared, this is also the hypotenuse of this triangle over here. So DC squared plus AD squared. So 100 equals, so notice I didn't have to even square root it because I need AC squared again. So this is 5 squared is 25 plus AD squared. So 75 is AD squared. Or AD is square root of 75, right? Which is 3 times 25 is 75. So it is 5 root 3. This is simplification needed to get to this answer. Okay? Got to be good with your radicals. Last one. In the figure above, angle A is congruent. This is a congruent symbol to AC, and BD bisects AC. What's the perimeter ABC? Okay, so if this guy bisects, this length is 7 and this length is 7, okay? And this is a right angle there, by the way. Remember that in the previous video I said, if you saw that video, there's that isosceles triangle theorem or something like that, where since this is an isosceles triangle and this bisects, so it should bisect those angles as well, and it's perpendicular and it bisects this line, okay? There's that theorem or something like that. So how can we use that to our advantage? Well, that's how we know this is a right angle. So we can get this side and this side as well. So these are congruent, by the way, because these angles are congruent as well. Okay? So we can just find one and then we found the other. So Pythagorean theorem again. So BC, all right, squared is 4 root 2 squared plus 7 squared, which is 16 times 2 plus 49. That is 32 plus 49. That is 81, right? So BC is equal to 9. So this guy is 9, this guy is 9. Perimeter is 14 plus 18, which is 32, right? Answer is A. Pretty simple. Okay, that's it for this video. Hopefully this was a good practice. These problems are pretty simple in my opinion. But if you need more practice, there's lots of problems online that you can search for, all right? Probably just Google like Pythagorean theorem problems or special right triangle problems, and then you can get some additional practice there, all right? Please like and subscribe as always if you found this helpful in any way.